with this update as well. Great. So I think without any further ado, I am going to give the floor to Murugappan, who is going to present the demo.
Okay, thank you, Maria. Hello, everyone. I am Murugappan Chetty. I am a principal engineer at Optum, and today I'm going to share my experience building some custom Knative event sources. And before that, let me share my screen. Can you share my screen? See my screen? Okay. So first, I want to say what's our association with Knative. Knative, we run it in our premises at Optum, and we support some serverless workloads. This is our setup. So you can find the usual suspects. We have serving, eventing, and for build for Tecton and Prometheus, Istio, and all those stuff. The only additional thing that we have is a set of APIs that we have on top of Knative and Kubernetes, just to make the barrier of entry really simple for the new users who are not familiar with Knative and Kubernetes. And we find a lot of users take advantage of that. Okay, and we are currently in production, running about like more than 500 services. The most of the use cases that I could see are atomic APIs, some automation functions, ETL processing, and popular sources. Since I'm going to talk about source today, Kafka source with Kafka binding, and followed by ping source and sync bindings. We also have some custom resources and some domain-specific resources, which I cannot share, but I'm going to share some of the custom resources that we built. Along with helping run this cluster, I also do some contribution to Knative and regularly attend the client working group meeting and the Hacky Hour on Friday. That's where I get the information about Knative. Okay. So today's demo, I'm going to give it in my Raspberry Pi cluster, and all the build is courtesy the new multi-arch support, and made things really simple. And yes, I could get the Knative contour nightly deployments. The only change that I had to do was, like as Matt mentioned, change the envoy to 116 from 115.1. Okay, so that is the deck that I have. So whatever I'm going to present today, I wrote it as a blog, so it's kind of easy to share than a deck. So let's start. So what is the Knative eventing source? According to the Knative documentation, it's a link between the producer and the sink. Event producer can be anything like a Kafka topic or a Redis queue or a GitHub thing. And then the sink is the one that's addressable resource within Kubernetes. Like it can be a Knative service or Kubernetes service, anything which could be resolved to a URI. And to find the list of addressables, there's the discovery API in the Knative sandbox that you could use to find out the addressables. And you can also here you can see the list of Knative sources that have been already supported by Knative here. There's a Knative dev documentation. So building a source boils down to building the link, which is called adapter within Knative, and how you build the adapter and how you ship it, how you distribute it with your teams. So that is what is like building the event source. And the main job of the adapter is to reach out to the producer, get the events, construct it as a cloud event, and send it to a sink. Why cloud events? There are like a lot of advantages. The main advantage that we could see is like the consumers that we built are interoperable and can be reused. I would, while showing the demo, I will show an example of that. And so for building this event sources, currently Knative provides like 3 options. One is a controller approach, second is a sync binding approach, and third is a container source approach. Controller approach is the approach mostly used by all the in-house Knative eventing sources, and it is a Kubernetes controller, and these are the components that you'll be building on that: an adapter, a controller, and a webhook. Adapter is the one that's going to produce the events, and controller is one that's going to operate the adapter. Webhook is optional. Suppose if you want to do some validation or some defaulting, you would need the webhook. Otherwise, you don't need the webhook. So building a controller can be a cumbersome process, but fortunately, there is a template project created by Knative called the Knative sandbox, and there's a Knative sample source in the Knative sandbox. You can just take this template project and get started from here. It comes with most of the boilerplate code. It also comes with the GitHub workflows and things like that. There's also a sample controller that could also be used. So using this approach, first I built event source called as GQL source or a GraphQL source. What it does is like GraphQL, as we know, GraphQL server, as we know, supports three operations: querying, mutation, and subscription. Using the subscription option, you can subscribe to a GraphQL server endpoint. And whenever there's a change in that particular entity, the server sends out that information to the whoever subscribes to it. So the source will subscribe to the GraphQL server and get the changes. And whenever there's a change, it will push it down to the sink. Using that information, sinks can do some action. I'll also show an example of like how this can be used. So before that, how I built this controller using the sample source controller. Just give some steps. I cannot go into the details, of course. But first step always in the API section, after defining the version, go and define the types that you want. And then along with that, there are some information about the lifecycle events and all these things you can create. So once you're done with that, you just need to change the boilerplate that's already given. Next step is to generate the code. So this part generates most of the code for you. There is a Kubernetes code gen and a Knative code gen, which is going to be used by the reconcilers. And the client, this is the client package, which is going to have all these information that was generated by this code. Okay. So once the code gen is completed, the next thing is to write the reconcilers. And for this also, there's a controller. You just need to confirm to the Knative's controller interface. So once you confirm to the Knative's controller interface and write the controller and the reconciler logic, the advantage that you get is you can make use of the shared main. So this is the entry point, and this is all the code that you have. Everything is like injected by this shared main, and there's a lot of work going on there. So you can go to the Knative package GitHub repository, and you can see what shared main does, like getting the Kubernetes clients config map reading, and then logging construction, this environmental variables reading. All these things are done by the shared main. And on a side note, the Knative package, it's like a gold mine. There is a lot of libraries there. Suppose we are building something for Knative and Kubernetes, always check out this libraries in the Knative package. There are a lot of supporting functions there. Okay, so that's about the controller. And in the controller, you can see all you're doing is like you're reconciling and then building a receiver adapter. And the receiver adapter is nothing but just a Docker image. So technically, it can be written in any language. You just need the controller just needs a Docker image. But if you have a I mean, if you write in Go, you can take advantage of the libraries that Knative gives. Okay, so that's about the controller. Next step that we do is to build the adapter. Similar to the Knative controller interface, there's an adapter interface that they have. And once you conform to the adapter interface, all you have to do is have the start method and then write a logic from here. You can make use of the adapter main. So this adapter main, just like the shared main, has a lot of code being done for you. You just need to follow that interface and then supply that adapter to the adapter main. So this builds the controller and adapter. I have not built the webhook in this process. I didn't need to. So once you're done with these things, the next thing is the easier thing. Like you go inside the config folder, there's a list of YAML files. You have to change it according to your needs. And then you define the shape of your source in the custom resource definition. And once it's done, you can just deploy this custom source in your cluster. And I have already deployed it just to save time. And I'm going to show an example of like how to use this thing. In this example, what I have is like a restaurant web application, wherein the menu information and the hours and the address information are there. And a restaurant manager can come in and change the menu information and address information. Whenever it changes, we want to tweet out these changes. So to do this, I created a GraphQL source. So this GraphQL source will subscribe on two queries. So one is on the menu items and second one is on the info items. And this is the GraphQL endpoint it's going to listen to. And then whenever there's an event that it needs to send, it will be sending to this Knative service. That is our sync. Okay. So I have all these things deployed, and I also have SMBot min scale to 1, so that I want to save time. Okay. So this is the application. So currently, these are the menus that are available. So when a manager comes in, and then if he wants to maybe add an information, right? Like suppose I want to add ice cream or something like that. Okay, I added a menu information here. So once this is done, the GraphQL server obviously would have sent the subscription to the source, and the source would have sent it to the SMBot. So you would get a tweet on this. Okay, so and similarly, if I go and remove some information, obviously again that is also going to come, I'm sure, here. So it says that it's gone. Okay, it's that quick. Okay, and if I have to show it in the backend, so I have this Knative source deployed, and I also have the restaurant. This is the restaurant application, and this is the GraphQL source that was deployed by the server, and I also have the Knative service that's going to process the information and tweet it out. Okay, so this is about the source that I built using the controller approach, and in some cases you wouldn't need the controller approach. In some cases you would want the Knative service itself to send out an event, or a Kubernetes job itself to send an event. In those cases you don't need a controller. So that's when you get the sync binding. You can make use of the sync binding. Sync binding is a custom resource again provided by Knative eventing. It's managed by the Knative eventing controllers, and all it does is, like, whenever you create a sync binding custom resource, it injects two environmental variables into the desired pod specable Kubernetes resource. A pod specable Kubernetes resource is one which has pod spec in its definition, like a Kubernetes job or a deployment or Knative service. And the injection is based on the labels and its namespace scope, if I'm not wrong. Okay. And you can make use of the Knative libraries to fetch the Ksync information and create a cloud events client. So from a developer standpoint, all you need to do is like build your events in cloud event format, and then you can make use of the client that is injected by Knative and then send the information out. So using this approach, build a source called as S3 source. Okay. The goal of this source is to reach out to S3 object store, any S3 compatible store like Minio or AWS S3. It can reach out to that any bucket and get the file that was specified, and it will send each line or multiple lines as a cloud event to the sync. Okay, this will be helpful for enterprises which process a lot of flat files, and in a flat file, each position in a line has a meaning, and so all they need is to process single lines. So this source would take the job of like going to the bucket and fetching the file and then taking the data and sending it to the sync. Okay, so here the main component is the Kubernetes job, and the sync is getting injected into the Kubernetes job, and that's what is like sending the data out. We chose the Kubernetes job because these files can be really big, like it can be like 5 GB, 10 GB or something like that. So we don't want the Knative service to be running that long. But at the same time, the Kubernetes job is like a one time, you cannot reuse it, right? So that's where we had a container image that could be run as Knative service. We'll create these jobs on the fly. So based on the bucket information and the file information, it will create a job. It will have some static information also, like the connection information to the S3 bucket. And using these information, the Knative service creates a Kubernetes job, and the Kubernetes jobs will send the information to the sink. So the Knative service has two endpoints. One is to create the Kubernetes job. Second one is to check the status of the Kubernetes job. So once it does this, the Knative service will scale to 0, and Kubernetes job will also will run to completion. Okay. So an example of like how you'd specify okay, how you'd specify is like this is the Knative service definition, nothing special, and this is the image you'll be using. This is a static image you'll be using, and this is the Kubernetes job image, which will be passed as an environmental variable called job spec. This is what this Knative service expects it to come from, and all the connection information will be provided as a secret, and it can take all these configuration items either as a environmental variable or as a query parameter to the Knative service. But all the secret information, all the connection information, you don't want to send it as a query parameter. Maybe you create it as a secret and mount it as a environmental variable. Mainly the bucket information and the file information is the one that's going to keep on changing. That will be passed as a query parameter. Okay. So where does the sync binding comes here? To explain that, I'll take an example. In this example, what we're trying to do here is like process a drug file. Okay, so this drug file is a CSV file. It has a list of drugs based on anatomy, and have two Knative services to process it. One service will split these file based on anatomy and upload it back into the S3 bucket, and second one is just a cloud events viewer. It will show it on the screen. So based on the sync binding labels, we can see how we can send the data to two separate Knative services. That's what I want to show here. So before that, to create, so what it takes to set up this S3 sources, there's a one-time process in each namespace per S3 connection information. So you create all the S3 related information secrets. Next thing is to you need to create a role binding so that the Knative service can create the Kubernetes job. Third one is you need to have Knative eventing core for the sync binding to be injected. And finally, you deploy this S3 source. This is a one-time process. You have the Knative service now up and running. Okay. Now the next step is to create the Knative services which are going to process this drug information. Okay. So this is the first Knative service, which is just a drug processor. As I told earlier, it's going to just split the file based on anatomy and upload it back into an S3 bucket. And as you can see, it will inject into the job which has this label, drug file source. Okay, and it will be sending to this sync. Okay, and second file that I have is like to send CEV's cloud events viewer. It's just an UI, and the match label for this one is like view drug file source. Okay, so I have all these things created already. Now I'm just going to invoke the Knative service to create the Kubernetes job to send the information out. Okay. First, before that, I just want to show. I'm not going to how to run KN with co-publish everything in a single line. So I don't know. I'm not going to wait for it to complete because this will be running in the default namespace. Okay. So you can see there's a co-publish platform is equal to all, or you can have AMD64 or Linux/ARM64, whatever you want. Okay. So once you do this, it's going to build for AMD64, ARM64, all those things, and then also create the Knative service for us. Okay. And now this is creating the Knative service. So I don't want to wait for this to do. This will work. Okay. So okay, first one is I'm going to this is my endpoint to call the S3 file source, and in the query parameters I passed this label drug file source and whatever is the bucket information and whatever is the file information. Okay, and currently you can see here the Knative, the S3 file source service is not running. Okay, so now when I run it, it's going to start, and once this is done, it's running the job now. Okay, and it's calling the drug processor Knative service. Okay, So simultaneously I'll run the view one also. So this is view drug file source. Okay, so this is my S3. Okay, so currently it had just the, now you can see the other files that got created just based on anatomy, and it got uploaded back into this S3 bucket. Earlier only this drug users files were there. Okay, now this is the cloud events viewer. So now all the events that were there got sent to the UI. Okay, um, so here you can see the advantage of sync binding there. So with, you don't need to change any of the Knative deployments. You don't need to change the destination. You don't need to change the source. Just by changing the labels, you can send it to like two different destinations. Okay. Okay, so with the first option and second option, you should be able to do most of the things. But the main disadvantage that I would see with sync binding is like, I mean, that's the way it is. You wouldn't be able to, sorry, so this is the way that you distribute this event source to other people. Like, this is a Knative service, and it's like people can fat finger and make some mistakes here. It's not like there's no CRD to do a validation or something like that. But at the same time, a lot of people don't want to create a controller because they don't have the expertise to do that. But still, if they want to have a controller which is managed by somebody else, then that's when you choose the container source option. Okay, so the only job that you need to do is to create the adapter, and you expect the container source to do the work for you. So for this, I'm going to use the FTP source by vlake. Okay, so this is the container source, and this is the only image, this is the adapter image that it needs, and this is the only responsibility of the user. Everything else is managed by the Knative eventing controllers. You pass all the args that you need to process, and all these environmental variables and args will be created as a deployment, and whatever sync information that you create will be created as a sync binding. Okay, so it's same as the sync binding only, but the Knative eventing controller is going to create the deployment and sync binding for you. Okay, so I don't want to show it in a terminal. There is a UI called Graph by Scott. So you can use this to display all the Knative services and sources within your namespace. And it also shows the connection between the source and the destination, right? So this was the advantage I was saying about cloud events. You can see like 3 connections are there, 3 sources sending information here, and I have a single consumer to consume it. So that is made possible by cloud events. And as I was saying, it creates a deployment and sync binding for the container source. Here you can see there is a container source also pointing to the destination, and also a sync binding for the SFTP watcher pointing to the sync binding. Okay, so what the SFTP watcher does is like it's going to watch for a FTP location, and it will be polling there. Whenever there's a new file, it's going to send the information to the sync. So I have an FTP server within the Raspberry Pi. I'm going to just upload information using the Cloudberry. So once this is done, you should be able to see the events here. It'll take some time for the, yeah, here you can see the information. So whenever the file was added, you can see the information here. So it keeps track of the latest time, and whenever there's a file after this timestamp, it keeps sending it to the Knative sync. And this file, this time is stored in a config manner, so you don't lose it when there is a crash or something like that. Okay. So these are the 3 options that we have to build the source. And as I told earlier, I explained the concept of the source, but apart from this option, if you have a different pattern, you can use that as well. And I've compared these 3 options. Might be debatable, so I don't know what to discuss here. So you can go through the, I'll share this link, and if you have any comments, please let me know. Yeah, that's all I have. Thanks for this opportunity.
Awesome. Thank you so much, Murugappan. And any questions or feedback about the demo that we want to discuss here as a group.
That was really awesome.